11.5 infinite geometric series. So S infinite equal to A over 1 minus R, provided that the R is between -1 and 1. Okay. In the previous part, 11.4 geometry series, we know that the Sn is A1 minus R power n over 1 minus R. This one for the R is between -1 and 1. And for this one is for the R less than -1 or the R greater than 1. Okay. So for the Sn, we have the limit n to infinity for Sn a 1 minus r to the power n over 1 minus r, provided the r is between -1 and 1. Okay, the r power n, we know that when the limit n to infinity, r to the power n will become 0. Why it is 0? Let's say the r is half. Let's say we have the r is half. When I have the power to 10, then it will become a very small number. If power to 100 and power to 1000, so approach to 0. So when my n go to 0, r power n will become 0 if the r is between -1 and 1. So this one will become a 1 minus 0 over 1 minus r. So the S infinity will be a over 1 minus r. So the S infinity, okay, they have a constraint that the r must be between -1 and 1. You try to imagine, let's say I have a series. We have the 1024, 512, and then 256, and so on. We know that the A is 1024, the R is 512 over 1024, that is half. So this one, when I go until one time, it will become 1. And then 1 over 2, 1 over 4, and become a very small number. Okay, a small, very small number that close to 0. Okay, a number that close to 0. So this one, we can have S infinity. That is the A over 1 minus R. That is 1024, 1 minus 1 over 2. So this is 2048. But if the R is greater than 1, let's say I have 1, 2, 4, 8, and so on. So the number will getting larger and larger. Okay, so we have a 1024 and then so on, a very big number until close to infinity. So sum to infinity, we cannot get a value. But for the r that is between -1 until 1, sum of infinity is a over 1 minus r. So this a as infinity does not exist. Okay,